Hello and welcome to Quantum IAS. In this video, we are going to discuss the question that was posted on the 7th of the December. Now, let us do the analysis. So this question is also a previous year question. And it is one of the most important topics you can mention in your syllabus. Okay. Also, it is from the mechanics section. And in mechanics, it is from the Rutherford scattering. Now, just look at the question itself. So here, the question is saying, considering the scattering of A, it is not A, it is alpha particle. Okay, alpha particle by the atomic nuclei. Okay, we know that the atomic nuclei was gold, but here we will consider is at a Ze number. Okay, some atom with the atomic mass Ze. Sorry, charge Ze. Find out the Rutherford scattering cross section. Explain the physical significance of the final expression, and it is of the 15 marks question. Right now, how can we start this answer? So we should start this answer by defining what do we mean by scattering and how it helps us, right? So we can write that scattering is the collision between two masses where the direction of motion of incident particle changes, right? Also, you can use other definition that the particle gets scattered or the diverges. Okay, so these are the things. Also, it is used to find the, what you can say, the interior of an atom. Okay, so we can write this much for the scattering part. Okay, now what happened in Rutherford scattering, you can write that in Rutherford scattering, alpha particles were bombarded on the gold foil which gives us the result of the presence of nucleus inside the atom. Right. So anything a small 1 or 2 liner about the Rutherford experiment you can write, 1-2 line about the scattering section you can write in the introduction part. Right. So now let's come to the, what do you mean by the scattering cross section? Okay. Now, before defining the scattering cross section, I'm going to define the differential scattering cross section. Right. So you can define it qualitatively as well as quantitatively, right? So it is the number of particles scattered per unit time per scatterer divided by the incident flux per solid angle. And what does it give basically? It gives us the probability. Okay. Gives us the probability of scattering. So I'm writing these things so that you will be able to understand the whole concept, but you should not write that many things, right? So you can simply write that d sigma by d phi d omega, right? Or simply you can say sigma omega, right? Can be defined as dn by d omega divided by 1 by I, right? And this is what we call the differential cross section. Okay. So basically what happened is, suppose if this is the target, okay, and if a particle is coming and getting scattered in this direction, right? If again a particle with this height coming and scattering with this side, right? So the angle, this angle that is made in solid, that we call it as solid angle, right? A 3D cone, you can say. The number of particles scattered in this direction with this solid angle is what we define the differential cross section. Okay. Again, if we wish to find the total cross section, right? Sigma basically is called the total cross section is equals to, right? So it can be written like this. Okay. Now come to our question, right? So what happened here? We have the nucleus, and here the alpha particle with 2 is coming, right? We can define an impact parameter here, right? The perpendicular distance, or you can say the minimum distance before the collision. Okay. So maybe you can define impact parameter, right? B is the, what you can say, the minimum distance to which a colliding particle can approach. Here the colliding particle is what? This helium particle, sorry, the alpha particle can approach the target if there were no force between them, right? So at this interval of time there is no force, it will not deflect anything, right? So what happened, it goes like this. Just I've given you. For the another parameter it goes like this, right? So what we can do here, we can just make a note here, that is, if this is dB, right, and if this is d phi, the number of particle crossing this thing, right? If you can make B and if you can make the dB, right? So this will be the cross section where the particles are coming, and if you can make the hole, this one, so it will be the cross section where the particles are scattering, right? So we know that the particle crossing here is dn, and the particle scattering here will also be dn. There is no loss of the particle here. Just keeping this in mind. Okay. So what we can write here, just try to understand. So dn will be, let's suppose intensity of the beam or the particle is I, right? I beam is incident on it. So what we can write here? So intensity is what? Intensity will be dn by dA equals to I, right? So what we can find out here, dn equals to y, I into dA. What is the elemental area? We all know that it will be what? 2 pi b into dv. But I am taking the mod here. I will tell you why. Okay. But let's suppose This was 2 pi b dv. I think you know this. If you take this segment here, right? So it will be what? 2 pi b, and this length will be dv, right? So the area will be this. dn equals to I 2 pi b into dv. Now, according to the definition of differential cross section, right? What we can write dn there? Okay. So dn can be written as I into d omega, right? That what we have studied here, that dn can be written as sigma omega into d omega into I, right? And we know this mathematical thing, right? This can be written as I into sigma theta 2 pi sine theta into d theta. Okay. And what is theta here? So this is theta and this is the d theta, right? So d theta is the corresponding 2D angle to d omega, that is a 3D angle, right? I hope you understand what do you mean by solid angle, what do you mean by the plane angle, and the relation between the solid angle and the plane angle. Okay. So if you don't know this thing, I can do it for you also. That d omega can be written as 2 pi sine theta d theta, where d omega is what? 3D angle, and d theta is what? The 2D angle. So this is the relation. You should remember this thing. These are the basic things. Okay. Now, from here, it was equals to what? I into 2 pi b, just we have mentioned there, into db, right? Mod db. So I and I will get cancelled. We need to find the sigma. 2 pi will get cancelled. So sigma theta will be equals to b sine theta db by d theta, or can simply write it as minus b by sine theta dv by d theta. Okay. So first understand this. What is minus doing here? So we know that, see, if you increase the impact parameter, its deflection get reverse. Okay. So what we can write here, that if b increases, theta got decreases. Okay. We can find it from the diagram also. Okay. So this is all about what we know, that the differential cross section area. Now, till now we had nothing to do with the, what you can say, the Rutherford scattering. Now what happened in the Rutherford scattering? So in Rutherford scattering, we know that the alpha particle were targeting on the particle, right? You need not to draw it multiple times. I am drawing just for your understanding, right? So what happened here, right? So the particle is here. Okay. So what is the force here? What we can write? So first one is, this is Coulombic force of repulsion, right? And it's a central force. We know that, right? Also, the collision is elastic, right? And there are no external torque here, right? So what we can write here, that if external torque is not here, what does it mean? Angular momentum will be conserved. Elastic, then what? Kinetic energy is conserved. And central force, that we can write F as FR R cap, right? And if the central force, so it will have no external torque. So these are the things that we know. Okay. So what happened? Just consider this. So it's coming with, let's suppose, PI, and it's going with PF, right? and this is the force of action that is acting here. Right? When the particle is here, the repulsion will be in this direction. Okay. Now, what we can do here is, if we can make the diagram here, right? If this is the theta, okay. So what we can make here, just I'm trying to simplify it. That the force will be acting here, and it see one thing. It need not that the force will be acting in the direction that is what you can say the parallel to the change in momentum, right? So it may differ because we don't know that where the change in momentum is here, right? So it can be anywhere, right? If a particle is approaching with this direction pi, and if this is pf, so basically based on the what you can say the magnitude of pi and pf, the change in direction will be anywhere. So let's assume that the force acting at this instant of time and the rate of change what you can say the in the momentum, right, will be having some angle, let's suppose phi, right? Now one thing I need to clear here, that the kinetic energy is conserved. Okay, so if kinetic energy is conserved, what we can write here, that pi whole square by 2m is equals to pf whole square by 2m. Let's suppose the mass of this particle, alpha particle, is m, let's suppose. So what it gives us, that modulus of pi is equals to pf, right? So both of them are equal. Now what we can do, just redraw this diagram. Okay, so I have already drawn it here. So just use the parallelogram law of addition, right? So what we will get here, so this direction we get delta p, and p and pf are same, and this is what we have defined theta here. Okay, so if this is theta and both of them are equal, so this angle and this angle will be what, equal. So what it will be the angle, so it will be simply, you can say the whole angle is what, pi. So this angle will be what, pi minus theta. So if you divide the angle, it will be what, pi minus theta by 2, and again pi minus theta by 2. Okay, so this will be the angle between them. So what we are doing here, to find out the differential cross section area, we need to differential cross section area, we need to find the relation between b and theta. So we are going to develop the relation between b and theta. Okay, so this was our b. Okay, now what we can write here, that delta p will be what, 2p sine theta by 2. Using the vector result, it's very easy to get. If two vectors are same and angle between them is what, pi minus theta by 2, you can simply get the delta p will be what, 2 pi sine theta by 2. Also what we know, that f dt is what, change in momentum, right? That is f into dt, integration is what, change in momentum. We know this because f equals to what, ultimately dp by dt, we know that, right? So what happens here, so at this instant of time, this is the instantaneous force and this was the change in momentum that we are seeing here. So what can be happen here, so we can put the f cos theta, or you can say phi, we have written here, phi dt integration is equals to delta p, just we have calculated, that is equals to 2p sine theta by 2. Now what we can do here, here it is phi and here it is theta, so we need to have a relation between phi and theta. So now comes the part of angular momentum. We know that angular momentum is conserved, right? So what we can write here, we can write that m omega r square, right, m omega r square is equals to mvb. So this was the initial angular momentum, and this was the what? You can say the final angular momentum, right? Also, you can write this term as mr square d phi by dt is equals to mvb. Why I'm writing this? Because at this interval of time, if it is moving with velocity v, right? So its angular momentum according to this frame, right? We are sitting here and we are watching the whole thing. So what will be the angular momentum? mvb, and here it is going at an angle what? Phi that we have mentioned. So here the angular momentum will be what? Mr square omega, that is uh, d phi by dt. So from here, what you can get the value of d phi by dt. Now just put it here. So it will become integration f cos phi, right, dt by d phi into d phi is equals to what? 2p sine theta by 2. We will now replace the p also here, but just understand this thing. Okay. Now here p is what? mv, right? Just put it here, bring it here. So it will become what? 2 mv sine theta. Okay. And this will be integration f cos phi. And what is the value of dt by d phi? So dt by d phi will be vb r square by vb, sorry, r square by vb, these are constant, into d phi. Now the problem here is what will be the range of d phi? Okay, so what we have just studied, try to, so this was delta p, right? And let's suppose force was acting in this direction and this was phi, right? So what can be the range of phi? So this was pi minus theta by 2 upon pi minus theta by 2. So the change in momentum can be anywhere between these two vectors only, right? It cannot go beyond two vectors. If we have two vectors, right, its change will be certainly between these two vectors. We know that. Okay, so if you subtract two vector, its resultant will be anywhere between the two vectors. Okay, so we can say that also these, if this is minus direction, this will be what? Positive direction. It is what? Clockwise. It is what? Anti-clockwise, or it can be positive, or this can be negative. Two complete directions. So if we have to measure the angle along this direction and this direction, these two measurement are completely opposite. So if it is plus, it is what? Negative. So here it will be from minus pi minus theta by 2 to what can say? Pi minus theta by 2. Cos theta d phi, you can know, the easily integrate this, it will be what? Sine theta. Also we can put the value of f here. So what we will get? 2 mv sine theta by 2. Okay, r square by vb we can take outside. Also what is f? So f is what? 1 upon 4 pi epsilon naught according to the Coulomb's law. Ze into 2e upon r square. Okay, cos phi d phi from pi minus theta by 2 to pi minus theta by 2. Sorry, minus pi minus theta by 2 to pi minus theta by 2. Right? Just do the calculation. So we will left with 2 mv sine theta by 2. Here r square will cancel out each other. So it will become what? It will become, so it will be 2ze square upon 4 pi vb epsilon naught, and it will be minus sine theta from minus pi by theta by 2 to pi minus theta by 2. Okay, you can put these things together and I can simply write you the result. Okay, so b, we need to find this b. Okay, so 2 will cancel out each other, v will be multiplied, so simply can write the b, that is equals to ze square 4 pi epsilon naught. And let's do one thing. Let's define E alpha here. Wait. So E alpha is what? Half mv square. Energy of alpha particle will be what? Kinetic energy. That will be what? Half mv square, because we do have here. So it will be what you can say ze square 4 pi epsilon naught, and half mv square will become 1 upon e alpha, and here cos by sine it will become cot theta by 2. Or you can simply replace these things, because these are what? Constant. Z square 4 pi epsilon naught, these are the universal constant. It will not change. So simply you can write these at C upon 2e alpha cot theta by 2. Where simply C is equals to 1 upon 4 pi epsilon naught ZE into 2e, which is basically you can 2 and 2 will cancel out each other to what? ZE square upon 2 pi epsilon naught, right? So that's why I have written C by 2e alpha, because it will become in the force, right? So force will become simply C by R square. Okay. Now, what we can simply we can find the sigma theta. It's a very easy differentiation, and you can get quickly. It will become what? Sigma E alpha square cos x square theta by 2. So this will be what our differential cross section for Rutherford scattering. Okay. If you wish to draw the graph, you can draw the graph also here, right? So it is something like this, right? Hyperbolic. And this point is theta is equals to 60 degree, right? So this is the sigma theta versus what you can say the theta, right? So here you can easily understand that when z is increasing, theta sigma theta will increasing. If we increase the energy, right, the sigma theta will decrease here also. Okay, so simply you can as long as the what you can say this graph is self-sufficient to define these things. Okay, now what we need to define, what was the question? That was sigma, right? So if you integrate this sigma, right, so you will get sigma tends to infinity, right? So if you can integrate the above, simply just write and integrate, you will get that sigma with turns to infinity, right? And what does it mean? That all of the particles go on through that, but it should not be the case. Okay, so what happens? What does it signify? That the total cross-section area is infinite. So it cannot be possible. Total cross-section area that if the target is here, how much area the target is providing for the scattering, right? How much the area target is providing for the scattering. So infinite makes no sense, right? Because why infinite? If you can see that we have taken some assumptions, right? And it is due to some assumption, and that should be your conclusion, right? That should be the conclusion of this answer, that we got the differential cross section area like this, and the total cross section will be infinite, and it was due to some assumption that we missed the screening effect of electron, right? Also some of the more assumption that we have taken for this calculation, right, this is due to this one, that interaction between two particles only, right? One target and one, what you can say, the nucleus. But in reality is what? There are number of target particles, and there are number of, what you can say, the projectile particle, or the particle that we have thrown in there. Okay. Also, all done in center of mass frame. Right. This is not assumption. You can add this value. This is not assumption. You can say not an assumption. That's a additional information that you can write there. Okay. Also, what we have taken, that the nucleus is very massive, right, as compared to the alpha particle. So nucleus is very massive, and only force is repulsive force. That is the Coulombic repulsive force, right? So what we have uh, come to the end of this question, and we can write these in conclusion, right? So now what I have explained this much to you, but what you should write, you should write the introduction, right, like this. Then the differential cross section area you should define like this. Then these things you have to do, but you can miss these steps, right? You can simply write this one, okay? Also you cannot do this mess. You can simply write this equation and this will be fine, right? Whatever the main thing, that angular momentum is conserved, right? So you can simply write this equation, right, and then put the value here, okay? So what I'm trying to say, you should minimize your mathematical calculation, okay? Also one more thing I want to tell you, that you can go to the quantumias.com website, and in the above menu you can click on the daily answer writing practice, and you should submit your answer, right? The more answer will be submitted, it will encourage me to make more videos on these topics, okay? So thank you and have a nice day.